Hello, I'm Canine, metric number 183847.
Hello, my name is Lim Pei Sing, metric number 182178.
I'm Daksha, metric number 185091.
Hi, I'm Mimi. Metric number is 181642.
I am Nushrafika, metric number 181652.
My name is Muhammad Abi bin Zahari, metric number is 183512.
So today we are going to have a group discussion on what's our topic?
Copper hepatotoxicosis.
Yeah,
I'm going to try to pronounce it as good as
Copper
I can.
storage
It's a copper
disease.
storage disease.
Yeah.
Okay. Let's talk about copper first. Copper is one of the trace minerals. In health, copper plays a role in the formation of a dog's bones, connective tissue, collagen, and myelin, known as the protective covering of nerves. It also helps the body absorb iron, making it an important part of red blood cell function. It also acts as an antioxidant, is a part of many enzymes, and is necessary for the formation of melanin, the pigment that darkens hair and skin. Copper is found in meat, liver, fish, whole grains, and legumes, and is typically added as a supplement to commercially prepared foods. Copper deficiency is extremely unlikely if a dog eats a nutritionally balanced diet. Problems are most often associated with copper excess, not generally from an improperly formulated diet, but instead due to inborn errors of metabolism that eventually cause too much copper to accumulate in the liver. At excessively high levels, copper results in oxidative stress, inflammations, and eventually to liver scarring, also known as cirrhosis and failure. Copper is absorbed primarily from the small intestine. Absorption is influenced by dietary copper content being increased when the copper intake is low. In the liver, copper is bound to ceruloplasmin, which become the principal form of copper transport in the plasma. Then,
We're supposed to talk about the disease itself, which is what is canine
Copper
hepatotoxicosis.
hepatotoxicosis.
Hepatotoxicosis. It is caused by an abnormally high amount of copper in the liver of a dog due to an inability to pass excess naturally occurring copper from a dog's food. This will lead to hepatitis, further hurting the liver, and also cirrhosis, which is scarring of liver over a period of time. This is believed to be caused by an inherited abnormal copper metabolism. The condition occurs more often in certain dog breeds, such as Bedlington Terriers, West Highland White Terriers, Skye Terriers, Doberman Pinschers, Labrador Retrievers, Spaniels, and Cachons are all canine breeds that are known to be often susceptible to copper storage hepatopathy. As many as 2/3 of the Bedlington Terriers in the United States have this disease. West Highland White Terriers often do not show the clinical signs of the disease, even though they may have high levels of copper. When it comes to Doberman Pinschers, gender is also involved in whether or not the dog may develop the condition. Primary copper liver disease generally fall into one of three categories. First one will be subclinical disease, a condition where the disease is present in the organ or body, but not detectable by normal signs or changes in form. Next one will be acute or sudden disease, which most frequently affects young dogs, associated with a condition that causes the death of liver tissue. The last one will be chronic progressive disease, in which symptoms are often observed in middle-aged and older dogs with chronic hepatitis, with damage and scarring of the liver.
Okay.
Yep, that's it.
Okay. So you said that it is a genetic disorder, right? So does anybody know what gene or what thing is involved?
Yeah. Yeah, I think it's I think it involves a protein which named COMMD1. It's a protein involved in various cellular processes. It belongs to a family of dense proteins, which all these 10 proteins contain a C-terminal motif called COMM domain. COMMD1 is associated with, let's talk about the functions. D1 is associated with multiple cellular process via interactions with wide areas of proteins. Many of these functions can be segregated into overlapping categories, such as iron transport, copper transport, inflammations, and free radicals scavenging. COMMD1 is initially discovered play a role in copper's metabolism in dog. It's found that Bellington's, as Tracy mentioned just now, Bellington's terriers homozygotes for a COMMD1 loss of functions mutations suffer from hepatic hepatotoxicosis. Several studies have indicated that COMMD1 mediated the previously export of copper through an interactions with the Wilson's disease protein, P-TAPS antipase.
Kelly, when you said homozygous for COMD1, loss of function mutation, do you understand what it means?
Okay.
The homozygous for COMD1 loss of function mutation.
Yeah, any idea?
It's like you know how we have heterozygous and homozygous, right?
Uh-huh.
So this is a homozygous, like when both the genes have the HOMD gene, it will lose its function. Mutations can cause it to gain function where it excessively does things, that's like cancer. It can cause it to lose function, or it can cause it to like what's the other one? It causes it to change its function to something else. So it's either changing its function, losing, or increasing its function. So this is a loss of mutation function. So that's why it cannot transfer the copper out through the biliary duct. That's why it's stuck there. It loses its function to transfer the copper out.
I see.
No, yeah, no.
Yeah, and then based on our current knowledge, it's tempting to speculate that the COMMD1 as the adaptose proteins to mediate the trafficking of the copper and rich vesicle, either dependence or independence of the copper transporting proteins, ATP7B. And then actually the COMMD1 is a multifunctional protein. Its name has been associated with several apparently distinct, but in many cases overlapping cellular processes is involved in facilitating the professional degradations of proteins, either independence or dependence to the ubiquitins.
So, like in our case, in this particular case, we were asked to see what actually happened, like what biochemical processes actually changed. So we, I feel like in a healthy animal, copper would be generally obtained from the diet, and this will be then absorbed in your gastrointestinal tract, and then that will be circulated to the liver, In the liver, it can either be if it's needed, it's transported out for cellular functions. If it's not needed, then it goes to the bile. It gets transported to the biliary duct. But in the case of, like you said, the COMD1 mutation, where it loses its function to actually throw out that excess copper, the copper stays in the body. And that copper that gets accumulated in your liver can result in lysosomal activity to increase. So you have too much copper, so the enzymes are coming in to break the copper down. But instead of just breaking the copper, they're also breaking everything that's around that area. So that's why it causes cirrhosis, because it sees too much copper as like the way of the cells saying that, oh my god, I'm in grave danger. So it breaks up all the cells. That's why all your liver cells are dying and you get cirrhosis. So your liver is actually scarring because you have too much copper. So that it's the same case in cancer as well. When you have increased, that's why for cancer you would need to have what are those antioxidants, because you don't want oxidation to occur. So in this case, when you have too much copper, oxidation will occur. So the lysosome will come in to prevent oxidation, but it will end up breaking all the cells and killing all the cells. So your liver will start losing cells, and that's why the liver is damaged and you get cirrhosis. So that's the altered biochemical process. So what do you think happens when this happens? Besides the ultimate, which is the liver, what are the other symptoms that we can see?
About the symptoms, but before that I would like to add the point of what she have talked about. What she talked about the disease earlier is the primary, and there is also the secondary. The secondary copper hepatopathies show symptom of the progressive side of the liver disease due to the chronic hepatitis or progressive cirrhosis. The liver disease in which the flow of the bile is slow or stop is known as the cholestatic liver disease. The abnormal flow of the bile results in the secondary copper retention. Okay, both of these types may display the symptom in their acute or chronic forms. There are for the acute, they have lethargy, anorexia, depression, vomiting, yellowish discoloration of the skin and the moist tissue. The moist tissue of the bodies are pale due to the low red blood cell count. Simply, we refer it as the anemia. The other symptom is the dark urine due to the presence of bilirubin. The disease is that this is what we call the bilirubinemia. Bilirubinuria. Bilirubinuria. The presence of the hemoglobin in the urine is known as the hemoglobinuria.
Because it has urine, so it has urea at the back.
Yep. For the chronic design, it also have the same symptom, but it's much more worse like that. Lethargy, depression, all have in the acute, but the different they have weight loss, diarrhea, excessive thirst and urination, abdominal distension due to the fluid built up in the abdomen, spontaneous bleeding, black or tarry stool, there is melena, the nervous system dysfunction due to the liver being unable to break down the ammonia in the body. That is what we call the hepatic encephalopathy. Okay, next I would like to tell you about the causes of this disease. It is important to note that dogs can be affected by the copper storage hepatopathy at any age. Genetics is the main contributing factor in this liver disease in the Bedlington Terriers, one of the breeds, and possibly the other breeds also have it. Here is some information that is known about the contributing the genetic factors. an autonomous recessive trait in the Bedlington Terriers due to the lack of the specific gene. Just like Kelly said, domain 1, COMMD1. It is the gene coding for the liver protein involved in the excretion of the copper in the bile is confirmed. At one time, possibly as many as 2/3 of the Bedlington Terriers either were the carrier of the gene or were affected by the disease. With the recent genetic screening, the incidence is now much lower. The genetic cause is suspected but unconfirmed in the breeds other than Bedlington Terriers. So the mode of the inheritance is still unknown. The prevalence in the certain line of Westland Highland White Terriers appears to be high, but the incidence in all West Highland White Terriers is low. As a report, 4 to 6% of the Doberman Pinschers may have the chronic hepatitis, which can be a cause of effect of the copper storage hepatopathy. Next, the method of the diagnosis were carried out in the lab. A laboratory workup will be conducted, including the chemical blood profile, complete blood count, and urinalysis. You will need to give a true history of the dog's health, including the history of the symptoms. And possibly incident that might have been precipitated in this condition. The history that were provided may give the veterinarian or other researcher clues as to whether the condition is primary or secondary origin. So the tissue sample will be taken from the dog's liver for the laboratory analysis. And the ultrasound image will be taken of the abdominal area to examine the condition of the liver.
So how would you avoid this in the future?
Okay, instead of prevention, I'll talk about the treatment first. It's okay. So basically, these dogs with excessive hepatic copper stores should have restricted copper intake. Well, that's just like our common sense lah. This is because limiting intake of copper will reduce copper loading, but will not facilitate a flow of excess copper from the body. Tissues with copper concentrations of more than 1000 ppm should be chilled with D-penicillamine for at least 6 months. Okay, what is chelation? Chelation therapy is actually a chemical process in which a synthetic solution EDTA, ethyl anidiamine tetraacetic acid, is injected into the bloodstream to remove heavy metals and/or minerals from the body. So during this chelation therapy, restriction of copper intake is especially important. If homemade diet is used, the USDA food tables could be referred to ascertain which foods are high in copper. So basically, organ meats, shellfish, nuts, and certain cereal rich in copper are to be avoided. So we could also avoid vitamins containing copper. So as for this chelation, we have 2 drugs involved. The first one is D-penicillamine, and the second one is trientine. So the D-penicillamine offers benefits beyond chelation in chronic hepatic inflammation, while trientine may be more potent in producing capriuresis, but has been associated with acute renal failure in a small number of dogs. So after this chelation therapy, oral zinc therapy is proposed by given 30 minutes before meal to curtail enteric copper uptake. Zinc includes metallothionein, which irreversibly binds copper in the enteric canal, where it is eliminated in feces. Long-term use of zinc may provoke iron deficiency. So for the D-penicillamine sequesters copper in an innocuous state either through direct binding or either induction of copper binding proteins, for example, metallothioneins. So it's also an antifibrotic effect through inhibition of collagen cross-linking and stimulation of collagenase activity. Treatment also has been shown to restore cellular glutathione, an important antioxidant, and to restore function of the nuclear macrophage system, increasing host defense against antigenic and or endotoxic insults. An anti-inflammatory effect suppresses activity of leukotrienes and prostaglandins. Okay, the penicillin also removes zinc and other essential metals from the body and can lead to ferrum deficiency anemia. That's why it's important for the co-treatment, which is the zinc treatment I just said just now. Okay. But after the chelation therapy, it's essential to continue to limit copper ingestion in food and water lifelong. Adherence to a copper-restricted diet and water source may obviate the need for continual chelation of zinc therapy. Okay, so as for the prevention method, as Paisley and Hafiz said about the breeds, that some breeds have more tendency of having this disease. So it's if any dog's lover feels like buying or adopt one of these breeds, the dog should be tested for the gene that causes this type of liver disease. We have a gene test for this. And then in the case of Bedington Terriers, one of the breeds, if its liver copper concentration is less than 400 mg per gram BW at 1 year of age, it is unaffected by the disease. So there are also clean lineage liver registries available for these breeds of dog. This will diminish our chances of getting a dog with this particular genetic defect. Okay, basically that's all what I found about the treatment and prevention.
You notice a lot of the disease actually happens in dogs that are like more of the expensive breeds, and like normal mongrels or anything, they generally don't get any disease because people don't like she said, like if you give them home cooked food, you're going to have a lot of raw stuff in them, so there's going to be excess of copper and a lot of things, whereas like mongrels and all, we just give them like dry food, so they get everything like just enough, and they don't get like excess of anything. It's sad. I think we're done for today.
Bradlington.
Okay.
I think that's all for today. Thank you.
Thank you.
Bye bye.
Bye. Last.